In this video, we're looking at how can we graph a parabola or a quadratic based on the transformations that are given to us. So here I have a formula for a quadratic because the degree is 2. I know that's going to give me that parabolic shape that is kind of that U. So something like this, whether it's opening up, or something like this if it's opening down. Um, and then we're going to use transformations. And transformations are how was the parent function changed in order to help us graph this. Now, because it is in vertex form, there's some things that I can see immediately. I know that my vertex is going to be at 1, 2. So if I wanted to, I can go ahead and plot that 1, 2. I also know because it's negative in the front, it's going to open down. So my shape is going to look something like this. However, because this is asking me about transformations, I want to do a little bit more than just try to sketch it in such as this. So my parent function here is squared. So I actually went ahead and have our squared, our just parent points here. So I chose some x values from -3 to 3. I plugged them in, and these are the y values that I got out. If I would plot this, I would just have our parent normal quadratic. But now I want to look at our formula, and I want to see what transformations do I see. Because this is a quadratic, anything that is inside of these parentheses is going to be considered something for the x direction. So those are the only things in the inside of the parentheses. So I see x minus 1. Now, any type of transformation that is dealing with the x direction, whether that's a stretch or a shift, and this one's going to be a translation, which is also known as a shift, is always going to be opposite of what we expect. So because I see x minus 1, that actually means I'm going to be doing x plus 1. Then anything outside of that, so my remaining numbers are this plus 2 and this negative, those are going to deal with my y values. And my y values do things exactly how they're supposed to. So the first one I'm going to do is take that negative, I'm going to multiply by my y values, and then I'm going to add 2. That is going to give me the actual coordinates for my transformed graph. So when I say that, I'm really going to be taking all of those x values and just adding 1 to them. So I'm going to start with -3. -3 plus 1 would be -2. -2 plus 1 is -1. -1 plus 2, -1 plus 1 is 0, so on and so forth. Notice that these kind of just look like they have been shifted, which is exactly what it is. So I just took 1 and added it to each of these values. Now the y ones are going to be slightly more complex just because I have 2 different operations that I have to do. So starting with this one, I'm going to plug it in, and that means that I'm going to do -9 plus 2, and -9 plus 2 gives me -7. I'm going to choose 4. I'm going to do -4 plus 2, and that gives me -2. I'm then going to do 1, -1 plus 2 gives me 1, and then 0. Well, -0 is just 0, so that gives me 2. I now notice that I've actually already done these operations, so my numbers are just going to repeat. That's because I already did 9 up here, so if I did 9 again, it would still give me -9 plus 2 gives me -7. So I took my original values, I put them through the transformations, and I was able to find my new values. I can now just go ahead and plot each of these. I'm going to use pink because it's my transform function. So I'm going to have -2, -7. I am going to have also 4 and -7. I can plot this at the same time. I have -1, -2. I also have 3, -2. I have 0, 1, and I have 2, 1. And I already had that vertex. Notice that this is the coordinate that we had decided was the vertex earlier. And this does have that downward shape. So if I connect all of these, I'm going to have that negative parabola shape. So we can list our parent points, find our transformations, and then apply those transformations.